Hello, my little 117ers. I am just going through a couple examples of x and y intercepts from yesterday. I'm also going to go over the examples in the notes for today, even though Ms. Trammel's also going to go through them. Just a little double reinforcement here. So this is example 3, I believe, from your notes, section A. This is finding the x and y intercepts. I'm going to start here doing example 3. So here's the deal, guys. Finding the x-intercept, okay? We're going to copy down the equation exactly as we see it. And the whole idea here is that we're actually plugging in 0 for y and then solving for x. Another way to plug in 0 for something is just to get rid of it, because 0 times anything is just 0. So that's why in class I was crossing things off. But if you cross something off and there's absolutely nothing left, you do have to write out 0. So this y becomes a 0. And then we have negative 5x plus 20. Now we're just going to solve like a normal equation and get x by itself. So I'm going to subtract over the 20, and I get negative 20 equals negative 5x. And then I'm going to divide both sides by 5, negative 5. And negative 20 divided by negative 5 is positive 4 equals x. So that is my value for x. But I'm going to write out my actual ordered pair as a point, or my actual x-intercept as a point. So my actual x-intercept is 4, 0. The x-intercept is always a number, 0. There's my x-intercept. I'm going to move this over, and if you didn't catch that, you can go back and rewind. To find my y-intercept, okay, we're going to do the same thing. So we're going to recopy down the equation. Negative 5x plus 20. But this time, we're going to cross off the x because we're trying to find y. And this one's a lot easier, guys. I'm left with y equals 20. Guess what? That's the answer. So my y-intercept is just 0, 20. And I'm done. Let's do another example. So number 4. Whoops, forgot to actually write in the answers. So this one is 4, 0. And y-intercept is 0, 20. Gorgeous. So now I'm going to go to example 4. Here we go. Let's do the same exact thing. X-intercept and then y-intercept. The x-intercept, let's write down the exact equation. And we're solving for x, which means we're getting rid of y. And now we're just going to recopy down the equation without the y there. 2x equals 24. We're going to divide both sides by 2. And that's going to give us x equals 12. Which means that my intercept is actually going to be 12, 0. Nice. Okay, as for my y-intercept, we're going to copy down the equation exactly as we see it. So we have 2x minus 8y equals 24. But this time, we're going to get rid of the x. And don't forget to drop down the negative with the 8. Okay, so I'm going to divide both sides by negative 8. And we get, let's see, y equals negative 3. So negative 3 is my y-intercept. And that's it, guys. So there's your x and y-intercepts. If you need to go back and rewind and rewatch, you can. But we're going to move on to the examples from the notes for today. So these are the examples from the notes for today. These are notes B, and we're talking about defining functions. When I write functions shorthand, or I write the abbreviation, it looks like that, FXNS, functions. So I know Ms. Schrammel went over this. Here's the key, though. Okay, if the x values in the points that are given to you repeat, then it is not a function. So let's see. I have a 2, a 3, a 4, and a 5. So do the x values repeat? The answer is they don't repeat. That's a good thing. We don't want them to. This is a function. We don't care if the y values repeat. The domain we just list the x values, 2, 3, 4, and 5. A little bit different than the domain we've done before. The range are the y values. I have a 3, a 3, a 5, and a 6. I don't care that the y value is repeated. And you only have to write down 3 one time. You don't have to write it down twice. There's my range. This is a function because the x values do not repeat. Number 2, my domain. We already know how to do this one, negative infinity to infinity, okay? My range bottoms up. So my y value on the bottom is a 0, and it's going to go up forever to infinity. Is this a function? Guys, for the function, we got to look at the vertical line test. The vertical line test. I love the vertical line test. I can't do the floating line here, but essentially, if you draw a floating line, or if you have the floating line, the line should only touch the function once at a time. It should never touch the function twice at a time. And in this case, it is a function because the vertical line test is passed. So yes, because it passes the vertical line test. The VLT, the vertical line test. Okay, next one. I have a table of values. Do the x values repeat? Let's check it out. We have a 4, a 1, a 3, uh-oh. The x values repeat here, so this is not a function. Okay, I could still write out the domain if I wanted, 4, 1, 3, and negative 2. And the range is my y values, negative 8, 2, negative 4, 9, and 10. But it is not a function because the x values repeat. And last, but absolutely not least, we have number 4. Do the x values repeat? Let's take a look. Negative 1, negative 1. I can stop right there. The x values repeat, so this is not a function. Domain, I could list out. We have a negative 1, a negative 3, and a negative 6. And the range is a 2, a 4, a 5, and a 1. That's it, guys. That's all you really need to know for today. So hopefully Ms. Trammell was able to explain that to you guys. And if you have questions, we'll answer those Tuesday. Have a good weekend.